So today's question is from computer organization, which was asked in GATE 2004 IT paper. Let's see the question. Consider a system with two level cache. Access time for level 1 cache, level 2 cache and main memory are 1 nanosecond, 10 nanosecond and 500 nanosecond respectively. The hit rates of level 1 and level 2 cache are 0.8 and 0.9 respectively. What is the average access time of a system ignoring the search time within the cache? Hey guys, I'm Pratik. Let's solve this one. So before solving further, let me explain you something about the cache memory first. So cache memory is like whenever a CPU needs some information, it goes into the main memory to get that information so that it can execute it. But next time when that particular information is needed by the CPU again, then it doesn't need to go to the main memory so that it can access that information. It can directly get that information from the cache memory, because as CPU was accessing that particular information multiple times, then CPU kept the information into cache memory so that it can access it faster than the main memory. So it is good to keep some information into the cache memory for the faster access. But we can't put all the information into the cache memory because cache memory is limited as compared to the main memory. So if in case a particular information is not present in the cache, then that time CPU has to look out into the main memory. So this is the concept behind the cache memory. Okay, let's see the problem. So it is mentioned in the question that they are using a two-level cache. Consider that this is a cache and main memory. That this will be a level 1 cache, then there is a level 2 cache, and then there is a main memory. Okay. So let T1 be a time to access level 1 cache. Where to access level 1 cache, it requires 1 nanosecond. So T1 will be 1 nanosecond. Let's T2 be the time to access level 2 cache, which is 10 nanosecond. And T3 be the time to access main memory, which is 500 nanoseconds. So it's like if the instruction is present in the level 1 cache, then CPU will directly get that instruction from level 1 cache. And if it is not present in the level 1 cache, then it has to look out in level 2 cache. And in case if the instruction is not in level 1 and in level 2 cache, then that time it has to check out in main memory. So in this way it works. And then there is also mention about the heat rates of level 1 and level 2 cache. Let H1 be the heat rate of level 1, which is 0.8, and H2 be the heat rate of level 2, which is 0.9. So these are the heat rates of level 1 and level 2 cache. So here heat rate of level 1 cache is 0.8. So whatever the instructions needed by the CPU, out of 10 times, 8 times CPU is getting a success in accessing those instructions from the level 1 cache. And if that instructions is not present in that cache memory, then it has to check out in level 2 cache, or if it is not present in level 2 also, then it has to look out in main memory. Okay. So in this question we have to find out the average access time. Let's find out then. There is a formula which says like that. Suppose that if there is a hit in level 1 cache, means whatever the instructions needed by the CPU are present in the level 1 cache. So in that case, to access level 1 cache, we need T1 time. Okay. Plus, if there is a miss in level 1 cache, means whatever the instructions CPU want, those are not present in the level 1 cache, then that time CPU is accessing a level 2 cache. So to access a level 2 cache, it requires T2 time. Plus, if the instruction is not present in the level 1 cache and it is not also present in the level 2 cache, so that time there is a need to access main memory. Okay, and in that case, to access main memory, it requires T3 time. So let's put all this information into the formula which we got now, which is 1 nanosecond plus 1 minus 0.8, which is the heat rate of level 1 cache, into 10 nanosecond plus 1 minus 0.8 into 1 minus 0.9 which is the heat rate of level 2 cache into 500 nanosecond, which is the time to access main memory. Okay, and when we compute all this information, we will get 13 nanosecond. So the average access time is 13 nanoseconds. Hey guys, I hope you got the answer. Thanks for watching.